In this video, we're going to discuss percent composition. Now, there are two primary ways that you can envision the composition of a molecule. One way is the amount of each individual atom that composes the molecule, right? So asking a question like, which atom is the most abundant, like which one has the most number of atoms in a molecule. And the other way to think about it is the contribution to the overall mass of the molecule, right? So in the previous video, we looked at the molecule for ibuprofen, and it had the molecular formula C13 H18O2, right? So kind of looking at this molecule through those two different lenses of composition, if we were just asking which atom is the most abundant in ibuprofen, you would say that the hydrogen atom is the most abundant. There's 18 hydrogen atoms there. Nothing else here is higher than 18. So hydrogen is the largest contributor to the molecule just purely by constituents, right? However, when we looked at the mass, there was a very different picture, right? So C13, so 13 carbons, when we looked at it, it had the mass of 156.13 grams. Those 8 hydrogens had the mass of 18.14 grams, and the 2 oxygens had a mass of 32 grams. So even though hydrogen is the largest contributor in terms of just number of constituents, as far as making up each ibuprofen molecule, when it comes to its mass contribution, it actually has the lowest contribution amongst any of the constituents of ibuprofen. And obviously carbon has the largest contributor. So one way that we can quantify this is using something called the mass percent, right? Mass percent. And this just basically gives you a percentage that quantifies the contribution of that atom to the mass of that molecule, right? So let's use a different example. Let's use a different molecular example. So let's use ethanol. So ethanol has the molecular formula C2H5OH, right? With alcohols, we usually have the OH at the end to signify that this is an alcohol. This is a defining characteristics of all alcohols, and so we put OH at the end regardless of the molecular formula, right? So, but basically here we've got 2 carbons, we got 6 hydrogens, and we got 1 oxygen in ethanol. Ethanol is the premier ingredient in most alcohols that people drink. So if you're of age to consume, you might be familiar with ethanol. So ethanol has this molecular formula, and what we can do is calculate the molecular mass. So just like we did for ibuprofen and methane in the last video, we can do the exact same thing here for ethanol, right? So, and I'm just going to go through and show the result, but you guys know how we get each of these numbers. We just basically, for carbon, we're going to do 2 times 12.01. So that's going to give you 24.02 grams of a contribution from those 2 carbons. For the 6 hydrogen atoms, its contribution is going to be 6.048 grams. And for the 1 oxygen, that's just going to be the atomic mass of oxygen, which is 16. Right, so if we want to get a complete molar mass for ethanol, that's going to be 46.07 grams, right? So this gives us the molar mass for ethane. So this is the weight of 1 mole of ethanol, right? So of ethanol, this is our molar mass. So what we want to do is take each one of these contributions, and we want to give a percentage of their contribution to the overall mass. So what we're going to do is take a ratio between the contribution of the mass from that atom and the total molar mass to give us a percentage that quantifies the contribution of that atom to the overall molar mass. So let's do that. So to get the mass percentage for carbon, right? So let's say mass percent for carbon is going to be equal to the mass of carbon in 1 mole of ethanol, right? So we're going to take the mass of carbon that's present in 1 mole of ethanol and put that over the mass of 1 mole of ethanol, right? So we're taking, oh, that's not meant to be 5 there. That's supposed to be another hydrogen atom, right? So taking the mass of carbon that's present in 1 mole of this compound over the total mass of this compound for 1 mole, right? So basically we're going to take this number that we calculated up top, right? So 24.02 grams in 1 mole of ethanol. And for the total molecule, it's 46.07 grams in 1 mole. And what you're going to do is multiply that by 100, right? So you want to take this ratio and then you're going to multiply it by 100% to get the percentage. So the mass percent of carbon in ethanol is 52.14%, right? So the mass percent of carbon takes up a little bit more than half of your total mass for ethanol, right? Just those 2 carbon atoms that's present, right? So that's how you calculate the mass percent, is you just basically take the contribution of that atom in 1 mole of the molecule over the total molar mass of the molecule, multiply it by 100%, and then you get your mass percent. Now we can calculate the mass percent of each one of the atoms that's present using the exact same method, right? So the mass percent for hydrogen, what I'm going to do is take that contribution from hydrogen, so this 6.048, over the mass of 1 mole of ethanol, 46.07 grams, right? And so that's going to give us 13.13%, right? So that's our mass percent for hydrogen. And then finally, we have oxygen present there, right? So the mass percent for oxygen is going to be its contribution per 1 mole, 16 grams, over the mass of 1 mole of ethanol, 46.07, right? I should put times 100 after each of these, right? So times 100. And so that's going to give you 34.73% for the mass percent for oxygen, right? So this gives you the total mass percent for each contribution of each atom in the molecule. And you can do this for any molecule. So you can practice this on your own without even looking at a specific problem. You can just take any random molecule that you want and you can calculate the mass percent for each atom involved in that molecule. Get the total molar mass. Then you can go to town with calculating each of these atomic percentages. And the last thing I'll note here is that, you should get something that equals up to 100%. So if you add all of these together, you do get 100%. So that's a way to do a little bit of a sanity check to make sure that your calculations were correct. You can add all of them together. You should get 100% if you did everything right. You may get a little, decimal point off if you didn't round correctly or made a rounding error. But outside of that, if you get something wildly over 100, wildly under 100, then you've made some sort of mistake. So that's a good little way to sanity check these mass percent problems.